Alright, today we're looking at finding the derivatives of the other four trig functions. So far we know the derivatives of sine and cosine. Now we want to know the derivatives of secant, cosecant, tangent, cotangent. Okay. So that's what we're looking at today. So to get started, we'll look at finding the derivative of tangent. Now, there's a reason why we waited till now to figure out what, or to tell you what the derivative of tangent, cotangent, and secant and cosecant are. Okay? And you'll see why in just a second. So, I obviously don't know what the derivative of tangent is, but do you have any ideas of what I could do to figure out what the derivative of tangent is? Change it into sine over cosine. Very good. So if I change tangent into sine over cosine, we're looking at that, and that we now have the ability to take the derivative of, whereas before we did not. Because what do I need to take the derivative of that? Quotient rule. Good. Very good, Teresa. So bottom times the derivative of the top. What's the derivative of sine? Cosine. Minus the top times the derivative of the bottom. What's the derivative of the bottom? Negative sine. Over the bottom squared. Alright, so let's clean this up a little bit. Cosine times cosine is cosine squared. Over there I have a negative and a negative, which makes that positive. Sine times sine is sine squared. And then I have over cosine squared. The numerator we should recognize, cosine squared plus sine squared is what? Speak up, I can't hear you. 1. What type of identity is that? That's a Pythagorean identity, so that is equal to 1. So this is equal to 1 over cosine squared. And what can I replace 1 over cosine squared with?
Secant.
Secant squared. So the derivative of tangent, we just figured out, is secant squared. Now obviously we do not have to go through all of that each time we want the derivative of tangent. Now, anytime I want the derivative of tangent, we automatically know it's secant squared. Desmond.
How did you get from cosine squared x plus sine squared x over to 1 over cosine squared x?
Because if you go back to last year, cosine squared plus sine squared is a Pythagorean identity, and that is equal to 1.
Okay.
That's this right here is equal to 1. So that means I can take that out and put 1 in its place, since they're equal to each other. And then 1 over cosine squared is the same thing as secant squared. So the derivative of tangent is secant squared. Okay? Now we could go through the same process to find the derivatives of the other three, but I don't feel it's necessary. So we're going to go ahead and give you the other three derivatives. Any thoughts on what the derivative of cotangent is going to be? Negative cosecant squared. Okay, and how'd you know it was negative? I did. Thank you for listening. I told you the other day that anytime I take the derivative of a trig function that starts with c, it has to be negative. So that's how we knew that it needed to be negative. So the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. Derivative of secant is, yeah, you're not going to know it. Secant times tangent. Okay, using that pattern, what do you think the derivative of cosecant is? Say again? Negative. We know it's negative. Cosecant and cotangent. So those are 4 new derivatives that you need to have memorized as soon as possible. Derivative of tangent is secant squared. Cotangent is negative cosecant squared. Secant is secant tangent, and cosecant is negative cosecant cotangent. Alright, so let's put them into action. I want to find the derivative of cosecant of 2x. The derivative of cosecant of 2x. Any thoughts on what this derivative needs to be?
Would be a product rule.
What?
A product rule.
It's not a product rule. It is a rule though. It's a chain rule. Why is it a chain rule? Okay, what's inside of what? Very good. So 2x is inside of cosecant, therefore it's a chain rule. Very good, man. So which one's outside? Cosecant is outside. What's the derivative of cosecant? Negative cosecant. Cotangent. And here's something you need to know. Anytime you're taking the derivative of a trig function, whatever is inside of it always needs to be there. Whatever is inside of a trig function always needs to say. So anytime I'm taking the derivative of a trig function and I have to write a new trig function down, such as cotangent, whatever is in my original trig function is always in my new ones if I have to write a new one. So make sure you get that. Am I done with this problem?
Yes.
No. What have I not done? Derivative of the inside. I have not taken the derivative of 2x yet. So times 2. So the best answer is negative 2 cosecant 2x cotangent 2x. And I can guarantee if something like this is on the AP test, bless you, something like this is on the AP test, that right there will be one of the answer choices. And a bunch of you will be suckered into choosing it. So make sure you take the derivative of the inside. Question on that one. Next one. And y equals secant cubed of x. Or secant x cubed. Okay, what do I have here? Any rules?
Yes, chain rule.
Chain rule. So what's the outside function, Desmond?
The chain. The x cube.
The cube is the outside function. Now, what we need to realize is that this right here can be rewritten as, or is the same thing as, that. Those two things are the same. So now, when you rewrite it like that, it's a bit more obvious that it's the chain rule. So my outside function is what?
3.
The 3, so I need to bring the 3 down. My new exponent is now 2, and now what do I have to do? Take the derivative of secant, which is secant x, tangent x.
At this time, we need seniors' last name T and U, and also we need seniors that are morning VOTEC and concurrent with the last name A through S. Again, seniors' last name T and U, and any seniors that are morning VOTEC and concurrent with the last names of A through S. Thank you.
So we can take secant squared times secant and get secant cubed out of it. So we end up with 3 secant cubed tangent. Question on that one. And y equals tangent of 3x squared. What do you think on this one? What do we have?
A chain rule.
Just a chain rule? No product. So we have 2 chain rules. Why do I have 2 chain rules, Peter?
Because it's squared and then
Okay, so the outermost function is the square. The next function is the tangent, and then inside of tangent is the 3x. So we've got a chain inside of a chain.
How?
Okay, so I need to rewrite that.
Yeah.
Like to see it.
To see it,
Yeah.
Yes.
Okay.
so we got the square on the very outside. Then we get rid of the square. We've got the tangent to deal with, and then we've got the 3x to deal with.
Okay.
And remember, every time I take the derivative of what's on the outside, what happens to the inside? It stays the same. So keep that in mind. So the first thing I want to take the derivative of is
Outside.
the outside, which is the 2. So I have 2 tangent of 3x, and it might be helpful right now to understand that that's in parentheses with a 1 out there. Why is that helpful? Or it might be helpful.
Because
Right. We're showing that we reduced the exponent by 1, and we're showing that the inside stayed the same. So I now have taken the derivative of the square. What's the next thing I need to take the derivative of? The tangent. What's the derivative of tangent? Secant squared. So I have secant squared, and the inside stays the same. Then I have to take the derivative of the 3x, which gives me 3.
So if it's like on the last one, it was secant cubed of x. So if there's something in front of x, you have 2 changes. Am I right? That's what it looks like.
You talking about that exponent in front of x?
Right.
Yes.
Okay. So like.
If you see that exponent on that trig function, there's going to be a chain rule. Yes.
Okay.
And if you need to rewrite it like we did here to see it better, then do it.
Yeah. I was just wondering, because like the coefficient in front of 3 or in front of x, does that change? Does that make that another chain rule? Because
Yes.
okay, because the other one was like secant cubed x.
Right.
So.
So on that one, it was just a chain rule. This one's got a chain rule inside of a chain rule. So it's got a double chain rule. All right, so if I clean this up, I have 3 times 2 is 6, and then I have tangent of 3x times secant squared of 3x. So I don't know if this will help visually, but you've got to make sure you're taking the derivative of everything. So the outside is the square. I took the derivative of the square right there. Then the next outside is the tangent. I took the derivative of the tangent right there. And then the next piece is the 3x. I took the derivative of the 3x there. Okay. So that's something that might be helpful, is to make sure you took the derivative of each piece. And there it shows me visually each piece and the derivative of each of them. Question on that one? When you get a chain rule inside of a chain rule, that's when it can get a little bit confusing. Alright, I have y equals cotangent of the square root of x. So what do we have here?
chain.
We have a chain. Is it just a chain, or is there a chain inside of a chain?
Just
It's just a chain. Good. So what is my outside function?
negative cosecant squared.
Cotangent is my outside function, and the derivative of it is negative cosecant squared. The inside stays the same. I have no clue where 3 came from. So that's the derivative of the outside. Now I have to take the derivative of the inside. And what have I told you the derivative of the square root of x is?
1 over the square root of x.
1 over 2 times the square root of x. Can I cancel those square root of x's out?
No,
Why not?
because
Outstanding. Now, when she says we can't mess with anything outside of the trig or inside of the trig function, and she is correct. So if it's inside of the trig function, know that it's got to stay. You cannot touch it. So negative cosecant squared square root of x over 2 square root of x is what we're looking for. So outside, derivative of the outside, inside, derivative of the inside. Yes.
How did the 2 squared of x go to the bottom? That was my question. Like after that, is it just because the one's on top, so it's just multiplied on top? That's fine.
Well, that, and you can think of this as that over 1, and then multiply straight across. Y equals 6 times cosine of x squared. What do you think? Chain? You think it's a chain within a chain or just a chain?
Let's change.
It's just a chain, that is correct. So, what is that 6? Coefficient, so what happens to it?
Stay the same.
Stays the same. So then my outside function is
So
cosine, the derivative of cosine is
second,
negative sine. So I'm going to put the negative there. Sine, the inside of the trig function must stay the same. You can never change. So there's the outside, there's the derivative of the outside. So now what do I need?
the inside.
Derivative of the inside. There's the inside, derivative of the inside is 2x. So can I make this sine of 2x cubed?
No,
No, why not this one?
because you cannot mess with anything inside.
Cannot mess with anything inside the trig function. So we're looking at negative 12x sine of x squared as our derivative. Question on that?
So it's okay to mess with the coefficient of the trig function.
Yes. Just not on the inside.
Alright.
Y equals 7 cosecant squared of x. So what do I have here? Chain. What's the outside function?
Square.
The square is the outside function. Okay, if it helps you, rewrite it as that.
So the 7's a coefficient?
7 is a coefficient, so what happens to it, Carson?
It stays the same.
It stays the same. Okay, the outside is the square, so the derivative of the outside is going to be 2 cosecant of x. So there's the outside, there's the derivative of the outside. The inside is cosecant of x, so what's the derivative of cosecant x? Negative cosecant cotangent. So if I clean it up, negative 14 cosecant cubed cotangent.
How'd you get the negative again? Because the negative from the second part?
Yeah, the negative from the second part, I brought it all the way out front. What property allows me to do that?
The multiplicative property. I know what it says.
How did you get cosecant? I get what you're trying to say. Just
Oh, it's not cubed, is it? It's squared. Thank you.
Ah, Dave all
What property is it?
multiplicative property of
You just take it.
Multiplicity?
What is that called?
That's commutative property.
commutative property of multiplicative.
I forgot these properties. I think they do.
All right, 2 more.
If I can actually do
Y equals the cube, or secant 2x plus 1 cubed. Y equals secant of 2x plus 1 cubed. What do I have here?
Two
So we take here,
changes.
I I have two changes, correct?
Change.
Alright, so the outermost function is
The cube.
the cube. So I bring the 3 down. So that right there is the derivative of the cube. Everybody agree? What's the next outermost function?
Secant.
Secant. So the derivative of secant is secant tangent. So that right there is the derivative of secant. And now I need to take the derivative of the inside of that, which is 2x, and the derivative of that is 2. So if I clean it up, maybe I was one problem ahead of myself. 3 secant cubed of 2x plus 1 tangent of 2x plus 1.
Me too.
Oh, sorry, yes, thank you. 6.
Oh my.
So there's my derivative. Alright, one more. Y equals 4 times secant of 3x times tangent of 3x. What do you think here?
Multiplication rule.
Product rule
Mention.
and a chain rule. Product rule and a chain rule. So what happens to the 4?
Stays the same.
It stays the same. So the 4 stays there. And then I have a product rule between those two right there. So I've got first times the derivative of the second. Derivative of tangent is
Secant squared.
secant squared. Am I done with the derivative of tangent? See, what else do I need?
You need the inside.
Derivative of the inside. So the derivative of 3x is 3. So there is first times derivative of the second. Plus the second times the derivative of the first. What's the derivative of secant? Secant times tangent. And also on this one, don't forget the derivative of
The inside.
the inside, which is 3. So first, derivative of the second.
We say why we have to do
But you got to take the derivative of the inside of the trig function.
Okay.
The derivative of 3x is 3.
So did you do the tangent or the product and the chain at the same time?
The chain is represented by sticking the 3 on there.
Oh, that's okay.
I wouldn't have a chain on this if what wasn't in this problem.
3x.
The 3x. If the 3x wasn't there, if the 3x was just an x, I wouldn't have the chain. I would just have a product. But since the 3x is there, I've got the chain, which means I have to take the derivative of it, and that's where the 3 comes from on both of them. Because the chain requires me to take the derivative of the inside. Alright, and anytime we do product rule or quotient rule, what do I want you to do?
Leave it up.
Take something out. What can I take out? 3 and a secant. So if I take out a 3 with the 4 that's already out here, it turns into 12. I take out a secant 3x, so let's see what's left. So what's left on this first piece?
Secant squared.
Secant squared is left on the first piece. Okay, and on this second piece, if I take the 3 and the secant out, what am I left with? Tangent squared, good. There it is.
Is it wrong to put the squareness on the right of the 3x?
Yes. So you put it on the right of the 3x, and the square goes to the 3x. put it in front, and the square goes to the 3 point. Good question. All right. Your assignment. Page 137, 45, 65 odd, and then 74 and 80.